Whether the presentation is visible to you?
Yes, sir.
Whether my voice is audible or not?
Audible, sir.
Oh, thank you. So we will continue with the next concept called as entity relationship model. So the idea is, for a given problem statement, you want to design a database. So the next idea is database design. So for designing a database, so what is the model we are going to use? So if you remember our previous discussion, so with respect to conceptual schema, you can use a model called as ER model. So the next discussion is about, for the given problem statement, how to represent a database in a diagrammatic format. So for generating that diagram, what are the notations you have to use? So what are the rules you have to follow for creating that particular diagram? So that is the next idea. So we will start with the overview of the database design process. So what are the various steps involved in the database design process? So for the remaining 2 or 3 classes, the entire discussion is based on a company database. So what I will do is, I will give you the problem statement with respect to the company database. Again, I have not modified the problem statement. So the entire I am going to use the same problem statement that is given in your prescribed textbook. So what are the various concepts related to your entity relationship model? So with respect to the concepts, today I will explain the idea related to an entity and an attribute. So what is an entity, what is an attribute? Again, with respect to attributes, what are the various types of attributes? And what is the notation with respect to entity and the various types of attributes you have to use in an ER diagram? Now, so first we will start with the overview of the database design process. So whenever we use the term database application, your database application is a combination of what? So your database application is a combination of database and some set of application programs. So your database design. So database design involves 2 main activities. One is your database design and another one is your application design. So what we are going to focus in this presentation is, or with respect to our syllabus, we are going to focus only on the concepts related to your database design. So various concepts related to your application design comes under the another topic called as what, your software engineering, another subject called as software engineering. So now with respect to this database design, so what we are going to focus is, so for a given problem statement, how to design the conceptual schema for a given database application. So your database is going to interact with various application programs. For example, for concurrency control, for ensuring integrity, for transaction management, for backup and recovery, we are going to have various application programs. So your database needs to interact with these application programs. So your application design focus on the programs and the interfaces that access the database. As I have already mentioned, we are not going to deal with this application design. Our entire focus is related to what? Our entire focus is related to the database design. So this figure highlights the overview of the database design process. So as part of the database design, what is the first step is, you need to, that is your database designer or your database administrator. I cannot use database administrator, database designer. So what is the role of the database designer? Database designer will interact with whom? Your database, the responsibility of the database designer is to collect the requirements. So for collecting the requirements, your database designer will interact with the end users or with the persons who are going to use the database. So what is the output given by your database designer? The requirements, your data requirements with respect to the database will be finalized by your database designer. So parallelly, what we are going to do is you are going to identify the various functional requirements. We are going to identify various application programs. So what are the various application programs and how they interact with how it is going to interact with your database. So once your requirement is finalized, what is the next step is? Next step is your conceptual design. So you are going to represent your requirement using a high level model or using a high level data model called as your conceptual model. So after completing the conceptual model, next step is you need to you need to implement that concept with the specific DBMS. You are going to identify a particular database management system and you will physically implement this high level model using using in that particular database management system. So that is the idea behind your logical design. And finally, in the lowermost layer, you are going to have physical design. As usual, that physical design deals with the various storage structure. So how your data will be stored in your secondary storage device. So what is the access path? What is the type of index you are going to use? So all those things is related to your physical design. So parallelly, if you want to provide support for transaction management, we are going to develop some application programs related to transaction management and the concurrency. So this is a brief overview. Our entire focus is on what? Our entire focus is on the conceptual design or how to create a conceptual schema or how to represent a conceptual schema using a high level data model. So that is our objective. Now, so before we look into how to create a database, first you need to you need to familiarize yourself with the database design process. So what you need to consider is, so with respect to the database, what is the table you are going to use? So inside the table, what is the key associated with that particular table and what are the constraints related to that particular table and for what purpose you are going to create the database. So with respect to the database design, you can categorize this database design into three categories. One is conceptual design, logical design and physical design. So what is the difference is your conceptual design is independent. So it is not specific to a particular database management system. So you can implement that model using any one of the available database management system. Whereas your logical design is specific to your particular database management system. So you are going to create a database using the given or using the identified database management system. And your physical design focus on what? How the database is stored in the hardware. So frequently we will be using these two terms, namely ERM and ERT. So ERM stands for your entity relationship model. ERD stands for your entity relationship diagram. So what is the basic difference is your ERM is going to be a logical representation of the data. So for a given application or for a given business scenario, so you are so the logical representation is called as what? A logical representation for the given business scenario is called as your entity relationship model. So for the same logical representation, if you are going to create a equivalent graphical representation, then it is called as entity relationship model. So now this is a simple example for your ER diagram. Suppose you assume that you want to create a database design for the university database. So now, what are the various modules with respect to your university database? So you need to identify what are, you need to identify the various components with respect to your university database. So now with respect to university database, what are the information you need to store? So you need to store the information about the teaching faculty, about the students, so various information related to the courses. So for example, so this is not a complete diagram, this is not, so for a brief discussion here I am using this particular ER diagram. So your student is called as a what? A student, lecturer and module. So you can see in this diagram we have used 4 different notation. One is your rectangle, second one is diamond shape, third one is oval and fourth one is straight line. So your entity will be represented using the rectangle. So attribute is represented using an oval and the relationship is represented using the diamond shape. So your straight line is used to connect the what? Relationship with an entity or an attribute with an appropriate entity type. So this name, ID and course are called as the attributes associated with the entity type called as student. Okay, student. So what is the relationship between lecturer and the student? Lecturer tutors the student. What is the relationship between student and the module? Student studies the module as part of each and every course. So now, next thing, what is the requirement is, so the thing is, like this, you will be having a problem statement. So for the given problem statement, what is the requirement is, you need to identify the entity, you need to identify the relationship, and you need to identify the various attributes. And you need to identify the various constraints. So that is the basic requirement. So this graphical representation is called as what? This graphical representation is called as your ER diagram or your entity relationship diagram. Now, so the next thing is, I will give you the problem statement. So now, what is our intention? You need to create a database for a company. So the thing is, so the design is based on what? So the database design is based on the following requirements. See, again, be clear. So hereafter, so the thing is, so this is the requirement given by a specific company. So immediately by seeing the requirement, don't come to the conclusion. So whenever we take a company, this is going to be the fixed problem statement. Okay, so see, usually what we try to say, if I give you a program, you can have n, you can create what n different solution for a given program, like that here. So if the thing is what, see, if I give you a generic problem statement, create a ER diagram for a university database. Each and every student can make their own assumption and you can create an ER diagram according to your own requirement. But the thing is, if the specification, so if I give you a detailed specification, then what you have to do is, you have to draw an ER diagram according to that specification. It needs to satisfy all the conditions that are given in that particular specification. Clear? So the thing is, so one is, so with respect to ER diagram, in the university, in the end semester examination, you are having 2 options. Sometimes they may ask you a generic question. Draw a ER diagram for a library database, draw a ER diagram for a hospital, draw a ER diagram for a tourism management department. So in that case, it is up to you to decide. Whereas, suppose if you are going to get a problem statement with a specification, just like what I am going to explain. So in that case, all the 60 students need to give the same solution. You cannot deviate from the what? You cannot deviate from the basic requirement. So what is the first requirement is, so the thing is, see, your company is organized into department. So now with respect to this department, what are the information you need to store? Each and every department is going to have a name. Each and every department is going to have a number. And for each and every department, you are going to have one particular person. See, in a department, you can have any number of employees. But if you see the condition here, an employee who manages the department. So what is the meaning? Whenever, so with respect to this company, you are having a department. So you are going to have one person acting as a manager for that particular department. Now in your database, what is required is, see the next point, you need to keep track of the start date. So from which date this person is acting as a manager for this particular department. So what you need to store is, you need to store this starting date. And another problem, another constraint is what? A department may have several locations. So again, because of that only I told you, see, suppose some other company, so in other case what I can do is, I can modify the statement as a what? A department may have only a single location. Whereas in our problem statement, it can have multiple location. You can have the same department in more than one location. So second one is, what each and every department is going to do is, each and every department is going to control some projects. So again, there is no constraint. A department can control multiple projects. So now what is the information you need to store with respect to project? See, each and every project is going to have a unique name, unique number, and see the difference, it is going to have a single location. So now if I am going to create a table for a project, what are the information I need to store? I need to store the name of the project, number, and what is the location associated with that particular project. So next one is employee. So inside the company, you are going to have various employees. So with respect to each and every employee, what are the information you need to store? Each and every employee is associated with the social security number, address, salary, sex, and birth date. Now see the condition. Each employee works for only one department, but work on several projects. Clear. So for example, if you map this to our university scenario, I belongs to what? So I am from ICT department, but I can take subject for whom? I can take subject for CSE, IT, ICT, different students like that. So each employee belongs to one particular department, but he can that particular employee is involved in what? He can work on more than one project. Now, see the next requirement. Now, what is the company policy is? So the company, so the thing is, as of now, with respect to this specification, the company is not going to give you a monthly salary for each and every employee. So what the company is going to do is, so the salary for particular employee will be determined by how many hours the particular employee has worked on various projects. Suppose, so the company is going to pay the salary on hourly basis. So what is the information you need to store? See here, you need to keep track of the number of hours per week that an employee currently works on each project. So what is the need for this information? This information is required for the salary computation. And finally, next thing is what? So each and every employee is going to have a supervisor. So I want to store the information about the supervisor. So you need to keep track of the direct supervisor of each and every employee. So next one is dependent. So the thing is, see, so this dependent is the information related. So actually I am going to, so for each and if you see the information for each and every dependent, so what are the information I am going to store? Name, sex, birth date, and relationship to the employee. So these dependents are not the persons who work in that particular company. So these are the, so the thing is what? For insurance purpose, I want to store the information about the dependent of each and every employee. So if for a particular employee, name of the spouse or name of the wife, so son name, daughter's name, so those information I want to maintain. So so all these information comes under the category called as dependent. Clear? So this is the problem statement related to the company database. So now, yeah, the company is going to have a department, your company is going to have a project, company is going to have an employee and the dependent. So now for this problem statement, what is expected from you people is you need to create a ER diagram. So as part of the database design, you need to create a what? You need to create a ER diagram. So this is the complete ER diagram with respect to what? With respect to the specification what I have given. So see here, so you are going to maintain the information about the employee, information about the department, information about the project, information about the dependent. You can see the various notations. So this is the correct solution for the specification what I have given. So what are the information you are going to store about the employee? So you can see the thing is, don't bother, I will explain each and every step in the next slides. So directly I have given the last step answer. Okay. So you can, as of now, you have a look on the various notations. You are having a what? Rectangle, oval, double rectangle. Okay. So single line, double line. Okay. Dotted oval. Okay. So here in some cases it is mentioned as MN. In some cases it is mentioned as 1N. So here you are having a relationship what? So this supervision is an example for recursive relationship. So now what is required is for a problem statement like this, you need to develop an ER. So if you carefully see the ER diagram, you cannot have a straight line connecting two entities. So I cannot draw a straight line from employee to department. So employee is an entity type. Department is an entity type. So these entities are related through a relationship. So that is the basic rule you have to remember. So you cannot have a what? You cannot have a straight line connecting two rectangles. If you are going to draw an ER diagram like this, the entire basic concept itself is wrong. You will get only 0 marks for that. So it shows that you are not familiar with the what? You are not familiar with the basic concept. So like that, you need to what? So we have mentioned some constraints, no? So a department, so an employee, okay? So in a department, you can have any number of employees. Employee work for only one department. So that is represented as 1:n. So these are the constraints. So what are the conditions we have given? So these are the constraints. Now, so we will start with the water. So I will try to explain the concepts one by one. So here, what are the concepts we have seen? So this is an entity type. This is a relationship type. So this is an attribute. So this SSN is an example for simple attribute. Name is an example for composite attribute. So location is a multi-valued attribute. Number of employees is a derived attribute. So I will explain the theoretical concept behind each and every thing. So now, so what is the first concept in your ER model? So the first concept is entity. So for a given problem statement, so your entity represent what? For the given problem specification, your entity represent the specific objects or things in the mini world, that is in the real world. So that is represented what? That are represented in the database. So it is going to be a what? An entity is going to be an object. So you can classify this object into two types. One is an entity may be of physical existence or it may be of conceptual existence. Physical existence means what? Physical thing. So for example, your person, your object, your place. So first three, okay, person, object, place. So these are example for your physical existence. So a person may be a what? A professor, or a person may be a student. A place may be a store or a university. An object may be a machine or a building. A concept may be what? Account or course. So for example, with respect to our thing, your project is going to be a what? It is going to be a concept. Okay. So it may be a what? Your entity may be of physical existence, or it may be of conceptual existence. So in the ER diagram, how to represent an entity? You are going to use a square or a rectangle. Okay. So this is the notation used to represent an entity. So the professor is an entity, student is an entity. So the first terminology related to your ER model is your entity. So next one, what is the second terminology? Second terminology is attributes. So I need some mechanism to further describe the entities, or each and every entity is associated with some set of attributes or some set of properties. So how to represent those properties associated with an entity? So for that I can make use of the attributes. So your attributes are nothing but the what? Properties that are used to describe an entity. So further, so it is used to give some additional information about the entity. Now, see, for example, if employee is going to be an entity, so what are the possible attributes you can have with respect to this employee entity? Each and every employee may have a name. This is with respect to our problem statement. Okay. So with respect to employee, what are the information you need to store? Social security number, address, salary, sex, and birth. So these are the attributes related to the entity called as what? Entity called as employee. Okay. So name, social security number, address, gender or sex, or birth date. So with respect to so this is a simple diagrammatic representation. Okay. So for a student entity, what are the attributes? Each and every student is going to have a name. Each and every student is going to have an ID or your registration number. So each and every student belongs to a particular course. So what is the notation you are going to use for representing the attributes? So your attributes are represented in a oval. And you cannot have a standalone oval. In an ER diagram, whenever you are going to have an oval, that oval needs to be using a straight line. You need to connect the oval to the entity or to the relationship type, that is to the diamond shape or to the square. So as of now, don't bother about the diamond shape. As of now, what is the rule is? So with respect to this entity, these are the three attributes. How to associate the attributes with this entity? You need to connect these attributes to the entity using straight lines. Clear? So far with respect to the ER model, I have introduced two terminologies. One is your entity, second one is what? Second one is your attribute. So entity is an object that is used to represent the mini world concept. How to further explore? So each and every entity is going to have some properties. How to represent the properties associated with the entity? You can use the concept called as attributes. Now, so if you take a specific entity, so for example, what I can say, each and every student. Okay, so with respect to this, so if you take, so inside this student, I can have what? So inside this entity, I can have any number of students, E1, E2, E3 like that, or S1, S2, S3 like that. I can have multiple students. So each and every student is going to have a name, ID, or these are the common information that is shared by all the students. Okay. So a specific entity will have a value for each of its attributes. So for example, the name of the employee may be John Smith, social security number, address, sex, birth date. So now what you have to remember is these are the values associated with one particular entity. So these values are called as value set. So what I am trying to say is each and every attribute is associated with the value set. So for example, what is the value set associated with your name? It is nothing but a string. What is the value set associated with your SSN? It is an integer. So each and every attribute is associated with the value set. Now this value set, we are not going to have a separate notation for representing this value set in an ER diagram. So instead of that, these value sets are modeled. So the thing is what, at the time of implementation, we are going to use the various data types provided by the programming language to express this value set. Okay. So now, so as of now, you are familiar with the two definitions. What is an entity? What is an attribute? So next idea is what depending upon the concept, you can classify the attributes into various types. So next terminology is types of attributes. Now, so first classification is, you can classify your attribute as a simple attribute or a composite attribute. So an example for your simple attribute is social security number or your gender associated with a particular person or a particular employee. So why this is called as a simple attribute? So as part of this attribute, you are going to store only single atomic value. That is, what they are trying to say is, further you cannot subdivide this attribute. See, I can have either M or F. So male or female. So I cannot decompose. So it is going to take only a single atomic value. So you are going to have a water. So you are going to have an attribute, and for that attribute you can give only a single value, and you cannot further decompose that value. Then that type of attribute is called as a what? That type of attribute is called as your simple attribute. So composite attribute. So it is a combination of what? Composite, more than one. So this attribute is a combination of several components. See, for example, address. So if you take an address, so your address is a combination of what? You can have an apartment number, you can have a house number, street, city, state, zip code, and the country. So the thing is, so you are not, see, in this case, if you take sex, it may be what? M or F. Whereas here, you are going to have what? You are going to have multiple values. You are not going to have a single input for this particular field. And another thing is, further what you can do? You can decompose this address, forming a hierarchical structure. So with respect to a name, person name, so employee name or a student name, so I can decompose it into what? So I can decompose this name into some subcomponents. So first name, middle name, and last name. So usually what you can do is, or simply what I can say is, you are having an attribute. If it is not possible to decompose that attribute, it is a simple attribute. If it is further, if you can further subdivide that attribute into some smaller attributes, then it comes under the category called as what? Some components, subcomponents, then it comes under the category called as composite attribute. Usually your composite attribute is represented in a hierarchical structure. See here, address. So what are the components for this address? Street address, city, state, and zip. So now again, this address is a combination of these four components. Again, what you can do? You can decompose this street address as a what? Number, street name, and the apartment name. So your address is an example for what? Address is an example for your composite attribute. So your attribute is further divided into what? Some simple attributes. So simple attributes attached with your original composite attribute using straight line. So this is the notation what you are going to use for the composite attribute. In the case of a, so this is the, so in the case of a simple attribute, only a single vowel. Single vowel will be directly attached to what? A single vowel will be directly attached to your entity. So now for example, so if you take our ER diagram, see here, your SSN is an example for simple attribute. Your name is an example for composite attribute. So this name is further subdivided into what? first name, middle name, and the last name. So here they have modeled this address. So now what I am trying to say is, so immediately by seeing this example, don't assume that wherever I am going to use the attribute address, always it is going to be a composite attribute. See, everything depends on what? Everything depends on your problem statement. See, as part of address, if I am going to store only city, then it is a what? Then it is a simple attribute. See, you can see, depending upon the value what you are going to store in that attribute, I can model the same attribute as a simple attribute or composite attribute. See, for this name, always I am going to store only the last name, means it comes under the category called as simple attribute. Instead of that, if I am going to store first name, middle name, and last name, it is a composite attribute. With respect to this scenario or with respect to this example, your address and name comes under the category called as composite attribute. Your SSN simple attribute. So next, okay, this already we have discussed. So next idea is single valued attribute and multi-valued attribute. So for some attributes, so how many inputs you can give? Always it is going to accept only a single input, or you can store only a single value for that particular attribute. So most attributes have a single value for a particular entity. So those attributes are called as single valued attributes. See, suppose, so practically you visualize this scenario. If I ask you what is your age, you will not say that my age is 18, 19, 20, 21. It may be 18, 20, 45, 46. Okay. So if age is going to be an attribute, it is going to accept only single value. So this is the notation what you have to use for representing the single value attribute. So next one is what? Multi-value. So you can have certain attributes. So for that you can store more than one input. So for example, again, so for example, if you take a entity called as car. So again, suppose in a particular model, if your car is going to have a combination of more than one color, then your color is an example for what? Color is an example for multi-valued attribute. And with respect to a person, if you want to store degree with respect to a person or degrees with respect to a student, your degree is an example for what? Multi-valued attribute. So the thing is what? So a person might have completed BTech, MTech, PhD, DSc, MPhil, MCA, like that. You can have a multiple degrees. So the thing is, see, suppose again repeatedly what I am saying is, so according to your problem statement, you are having a car, and if that car is going to have only single color, then it comes under single valued attribute. So now what the thing is what? See, you need to design this, you need to design the database for a generic fashion. That is, it need to accommodate all the constraints. In future, if you want to add some constraint, means you should not start from the scratch. Initially, see, suppose as of now, if I am going to store the information about undergraduate students, this degree may be what? Degree may be your simple attribute, single valued attribute. Suppose if I want to store the information, those who have completed, those who are working for past 10 years or 20 years, there is a chance for what? I cannot say that all the employees in a company are going to have only single degree. So in some situation, they may be having multiple degrees. So I need to model this as a what? I need to model this degree as a multi-valued attribute. So what is the notation? Double oval. In a ER diagram, whenever you see a double oval, what comes to your mind? So it is going to be a multi-valued attribute. Single oval, it is going to be a what? Single valued attribute. Clear? First category is simple attribute versus composite attribute. Again, so if you come to our ER diagram, see here, location. So if you recall the problem statement, what is the last statement? Your department can have multiple location. So your location is have a what? Your location is represented as a multi-valued attribute. So with respect to project, see here. So the thing is, so with respect to department, you have stored the location. With respect to project also, you are having an attribute called as location. With respect to project, location is a single valued attribute. With respect to department, your location is a multi-valued attribute. So it depends on the problem statement. Clear? So first thing is simple attribute versus composite attribute. Next one is single valued attribute versus multi-valued attribute. Next thing is stored attribute versus derived attribute. So what is the notation used for representing the derived attribute? Dotted vowel. So what they are trying to say is, see, if you are going to store the attribute as part of the database, then it comes under the category called as stored attribute. So now, see, with respect to a student, it is enough if I store the date of birth related to a student. So unnecessarily, I don't want to waste some space, or I don't want to add some additional burden to your data entry operator by adding another field called as age. So simply what they are saying is, so these two fields are what? These two attributes are related. Or you are having a relationship between these two attributes. If data, see, it is enough if you store the date of birth in the database. If the date of birth and the current date is known to you, you can compute the what? You can compute the age. Now what they are trying to say is, see, at the time of displaying some information to the user, you want to display the age. Only this age is used for display purpose. In that case, explicitly don't store this age as part of your database. So date of birth is an example for your stored attribute. Age is an example for your derived attribute. So this is the notation you have to use for your stored attribute, and this is the notation you have to use for your derived attribute. Clear? So again, if you come to our ER diagram, so see here, number of employees. So now simply what they are saying is, see, you have stored some values in the department. Simply, if in SQL you are having one built-in function called as count. If I use the function count, I can retrieve the what? I can retrieve the total number of employees working in that particular department. So what they are trying to say is, see, in some situation there may be a need to retrieve the number of employees, but I don't want to store the number of employees as part of the department. So this dotted vowel is an example for what? Dotted vowel comes under the derived attribute. All the remaining things are stored attribute. Okay. The next idea is null values. Okay. See something. So in some situation, what they are trying to say is, okay, suppose you take you are having some attributes. Input for certain attributes are mandatory, but certain attributes are optional, or you may not know. Okay, see, suppose you cannot say that I am going to store the information about an employee. All the employees are graduated, or all the employees going to have some information related to degree. You cannot make it as a stringent requirement. But all the employees is going to have an age. All the employees is going to have an height. So you want to store the information about a house. So always you cannot have an apartment number associated with the house. Okay. So if it is going to be a single house, you may not have an apartment number. So these two things comes under the category called these two attributes, that is apartment number or college degrees. These two attributes comes under the category called as not applicable. So for that particular entity, it is not applicable. See, if my house is going to be a single house or an independent house, I don't have an apartment number. I will be having only house number. Okay, so see, the thing is, so you are having a person. Okay, so the thing is, he is not having any college degree. Okay, in that case, so you will be having what? So this college degree is not. Suppose one person is working as a watchman in your company. So the thing is, so you cannot expect a what? A college degree. Okay, so he might have completed up to school education. So in that case, college degree is not applicable to that particular student. So in that case, what you can do is you can use null as an input. Again, be clear. Null means it is not a blank. That is, if the data type is string, it is not blank. If the data type is integer, it is not zero. Null means currently the value for that particular attribute is unknown. So currently my house is going to be an independent house. In future, I can modify my house into an apartment. At that time, my house may have an apartment number. So null means as of now, currently the value is not known. So when to use null, one is the value is not applicable to that attribute, and second one is value is missing. So you are storing the information about a person. One attribute is height. You cannot give water, so you cannot say that it is not applicable for the person. Whenever you are going to have a person, he is going to have a water height associated with that person. What I can say is I have not measured the height, so as of now I don't know the height of that particular person. So in that case, missing value. So the data is missing for water. Data is missing for that particular person. In some situation, so as of now, we don't have a condition saying that in each and every house you should have a landline number. So if you want to have a mobile number, if you want to have a mobile, you should have a landline. Like that, we don't have a condition. So suppose I don't know whether that particular person is having a landline or not. So that unknown information or missing information, to represent the missing information or unknown data, you can use this null value. Clear? So null? So the thing is, your null is not an attribute. So null is a value what you can use for the attribute. So last category is complex attribute. So this is similar to what? Hybrid inheritance. So what I can have is complex attribute is a combination of what? Is a combination of two types of attributes. So I can have a composite attribute and a multi-valued attribute. So I can go for what? I can go for some sort of nesting. So those nested attributes are called as complex attributes. Now suppose you consider this example. So for each and every student, I want to store the information about the previous degrees. So now your previous degree is going to be a what? Composite as well as multi-valued attribute. Okay, see, previous degrees. So what are the so the thing is what? Okay. So why this is called as composite? As part of previous degree, I want to store the information about college, year, degree, and the field. So I can have multiple previous degrees. So you can have multiple previous degrees. So what I am going to do is I am going to model this previous degree as a combination of what? As a combination of complex attribute. It is a combination of what? Multi-valued attribute and a composite attribute. So your previous degree, I can have multiple previous degree, and if you take single previous degree, what are the components it is going to have? It is going to have 4 subcomponents, namely college, year, degree, and field. So that's all with respect to your attributes. So as a summary, so I have started with the overall view of the database design process. So logical design, physical design, conceptual design. So I have given the very detailed problem statement with respect to your company database. So it is not my own problem statement, it is the problem statement given in your prescribed textbook. So with respect to the company, we want to store the information about the employee, department, project, and dependent. So we have added some constraints. So I have started with the basic terminologies related to the ER model, and I have completed the discussion with respect to 2 terminologies, namely entity and the attributes. And finally, you can classify the attributes into various types, and I have listed what are the various types of attributes, and I have given the idea about the null value, when to use the null value. Thank you. So if you are having any doubt with respect to today's discussion, you can ask. See, from tomorrow onwards, I will start with the second unit. So I need 2 more lectures to complete the remaining topics related to ER diagram. So for those 2 lectures, what I will do is I will upload the pre-recorded videos. So yesterday itself, I have completed the recording for the remaining concepts in ER diagram. So I will upload the remaining pre-recorded videos. So you go through all those videos, and finally in the next class or coming Thursday, we will have a discussion for 10 to 15 minutes. So from the first class itself, I told you the number of hours given for this subject is very, very less. So then and there, what I will do is I will upload the pre-recorded videos. Okay, so first we will start this as a trial. See, there are only 2 options. One is I need to go with the pre-recorded videos. If you are not comfortable with pre-recorded videos, if you want me to directly explain, then what I need is I need your cooperation. We need to identify some additional period which is common free hour between you and me, and I need to take some extra classes. So you decide and you tell me. Okay. So I think so from next, if you recollect the concept related to your second unit, it is related to SQL. So from next class onwards, we will be having what are. So mostly I won't use PPT. I will share my SQL editor. Directly I will execute the SQL commands. In the class itself, I will type the commands. I will give the syntax. I will give the purpose. So that we will have some sort of interactive session. Okay. So how many of you are familiar with SQL? So if you people are familiar, then directly what I will do, I will skip the second unit and I will go for the third unit. Some of you might have studied SQL as part of your 12th standard, or already if you have completed a course in SQL. If all, so almost 40 students are here. Only regularly attendance I am having only 40 students. So if you are familiar in SQL, I will skip SQL. If you want me to explain SQL, I am ready. I will explain the concept related to SQL, data definition language, data manipulation language, transaction control language, all those things. So for hands-on practice, in your laptop, you install Oracle NG. If you don't have that, you you put a message in the chat window. I will share that software in the Google Classroom. You can download it and you can install. So I don't have any idea about the online options and all. If you are comfortable with online options, you can go with that. But my suggestion is in your laptop you install 10G, because I will share the problem statement. So you need to store the database and you need to execute some queries. So for that, it is advisable to install 10G in your system. Okay. So don't go with some higher versions, because you may be having some cloud supporting 12G and all. Okay. So the thing is, this is with respect to the content given in your unit 2. I think this version is enough. If you have any doubt, you can ask.